Hello, class, and welcome to Thursday, March 19th NTI day. So we're on Unit 8, Lesson 5, more about estimating probabilities. So it says, let's estimate some probabilities. The learning target is I can calculate the probability of an event when the outcomes in the sample space are not equally likely. I can explain why results from repeating an experiment may not exactly match the expected probability of an event. So our success criteria is given a question about a spinner's probability of landing on a section of that spinner. I can determine the most likely outcomes. So what we should be doing during this is taking notes. The student task statement should have a make a copy option for you today. So looking at the first activity, warm-up activity, is it likely? If the weather forecast calls for a 20% chance of rain, would you say it is likely to rain tomorrow? So I included a visual for you. So this is what 20% would look like, or 1/5. So we know that no, it is not likely to rain tomorrow. So the second question in the warm-up, if the probability of a tornado today is 1/10, would you say that there will likely be a tornado today? So if you look at this visual, you can see that there's a very small chance for a tornado. So it is not likely to have a tornado today. In fact, there's a less chance of having a tornado than having rain, if you compare these two. So if the probability of snow this week is 0.85, would you say that it is likely to snow this week? If you look at the graph, you can see that the dark purple is the chance of snow this week. So yes, it is very likely to snow this week. So the whole point of this warm-up activity was to get us back to thinking about probabilities and how to solve for them. So you are next going to click on this link for 5.2, making my head spin. So if you click on that link, it should take you to this page. On this page, there are 4 spinners. And what you're going to do is you're going to spin each of them 10 times. So each one's going to be spun 10 times each. So I'm not going to do this for every single one of them, but you get the idea. So if you spun it this time, you got a 3, you would put that down as your first result. And if you keep doing it, this is another 3, so you put a 3 down as your second result. So you'll do that for each spinner 10 times and record your outcomes. So I already have recorded my outcomes. So for spinner A, I got a 6, 1, 4, 2, 3, 4, 6, 6, 2, 2. So you do that for all 4 spinners. Once you've recorded your results, did you get all the possible outcomes in your 10 spins? So this is all depending on your spins. So I look over here, and the spinner for A only goes to 1 through 6. If you look over here, you can't, it looks like there's no 5. I never spun a 5. So for spinner A, I did not spin a 5. So for spinner B, if you look up here, you can see that I did not spin a 1 or a 3. So I missed that the first time. There's no 3 up here. So for spinner C, I did not spin a 2. Oh, I did spin a 2. I did not spin a 5, 6, 7, 8, or 10. So if you look up here, you don't see a 5, 6, 7, 8, or 10. And so for spinner D, you should get all the different possible outcomes. So the second question, what fraction of your 10 spins landed on 3 for spinner A, B, C, and spinner D? So for A, we're looking for the amount of 3s we got. So we can see there's only 1 3 we got out of 10. So for spinner A, you had a 1 in 10 chance, or 10%. So this 1/10 could also be written as 10%, or 0.1, just showing you another way to write a probability. So for spinner B, we were looking for how many 3s we spun. Well, we didn't spin any, so 0 out of 10, so 0%. For spinner C, I spun a 1, 3, 9, 4, 4, 1, 11, 4, 11, 2. So there's only 1 3 in there, so I got a 1 out of 10 chance. For spinner D, there's only 1 spin that had a 3 on it, so you have 1/10. So now we move on to the next questions. So do any of the spinners have the same sample space? If so, do they have the same probabilities for each number to result? So if you look at the first 2 spinners, spinner A and B, you noticed that they have the same sample spaces. So remember, sample space is the range of values that you can get for an outcome. So for spinner A, it's 1 through 6, because there's 6 different numbers you can draw. For B, there are also 6. So they have the same sample space. If you go down to C, go through 1 through 12. So you know that the outcomes could be different. And for D, they have 1 through 4. So we know that A and B actually have the same sample space. So sample A and B have the same sample space. Spinner A and B have the same sample space. So if they do they have the same probabilities for each result of the numbers? So let's just look at, for example, on both the spinners, A and B. Let's look at 4. So if you can see on spinner A that 4 comes up twice. For spinner B, 4 comes up 1, 2, 3 times. So they don't have the same probability for each number. They do not have the same probabilities for each number, because there are 2 4s on spinner A and 3 4s on spinner B. So for each spinner, what is the probability that it lands on number 3? Explain or show your reasoning. So for spinner A, let's just look there. So we know that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different outcomes, or 12 different spots that the spinner can land. So for 3 here, you have 2 out of 12 chance, a 2 in 12 chance. So you can actually round that down. So spinner A has a 1/6, 1 out of 6 chance, because 2/12 is also the same thing as 1/6. For spinner B, you have 1, 3 out of 12. So 1 out of 12. So it has a 1 in 12 chance. Spinner C has a, let's see, what spinner C has 1 option out of 12 as well. So 1/12. And then spinner D. So this is, if you look at it, actually there's a 1 out of 4 chance on spinner D to get a 3, because this looks like about 1/4 of the entire spinner. So spinner C, or spinner D, has a 1/4 chance. So for each spinner, what is the probability that lands on something different than number 3? So spinner A, all you have to do is do 1 minus 1/6, which is 5 in 6 chance. Has a 5/6 chance. Spinner B has a, you can also look at what can we add 1/12, what can we add to 1/12 to make it 12/12? And that would be 11 out of 12 chance. Spinner C has an 11 out of 12 chance as well. And spinner D has a 3/4 chance. So you're just completing the fraction to make it a whole. So what this means is for spinner, let's take spinner D for example, has a 3/4 chance of being something other than a 3. So that's basically saying this whole area is 3/4 of the circle, which it is. And then, so the other chance, there's a 1/4 chance of getting a 3. So for the 6th question, Noah put spinner D on top of his closed binder and spun it 10 times. It never landed on the number. So for number 6, if it never landed on number 1, then it's on top of a closed binder. So think about a white binder, how if you sit on a table, the binder slants a little bit either downward or upward depending on how much stuff you have in it. So since a binder is sloped, gravity could have pulled the spinner away from the number 1. From number 1. So Han put spinner C on the floor and spun it 10 times. And it never landed on the number 3. So he says the probability of getting 3 is 0. How might you explain why this happened? So this is really important. So we're looking at spinner C. So he spun it 10 times and he didn't get a 3. So there's a couple explanations as to why this could happen. So we know there's a 1 in 12 chance that Han would get a C on this one. So you actually know that the probability should not be 0. I think everyone. So Han could have spun the spinner incorrectly. That is possible. Or he did not do enough trials. So he did not spin it enough because there Our